enjoy it. I hope you are all well and safe. So let's do that. Thank you for being here today. So I hope you've been enjoying the session so far, and hopefully many more fun to come. I'm really hoping that you will be enjoying our session for now. This is a gentle introduction for CI/CD and DevOps in general, because at the end of the day, it is a practice, one of the main practices of DevOps. So if you don't know what is CI/CD, this is fine. We'll begin with from the zero. I'm leaving it till the end of the session so that you will see it by yourself and then you will get the idea about it. If you have some background, also we'll also be trying for AWS services when it comes to CI/CD. So before starting, I have to introduce myself. So my name is Fatema Mannaei. I'm a cloud application specialist and I'm leading AWS Bahrain user group. And let me tell you this, user groups and communities is a great hack when it comes, it's a great hack when it comes to knowledge and experience. It allows you to extend your individual single experience to many others. So don't hesitate to follow us on any of the channels, Instagram, Twitter, or Meetup to check our latest event. And not just Bahrain user group, Beirut, Riyadh, a lot, around 6 user group are participating to build the community day of today. So don't hesitate to follow us and see the latest event, especially with COVID-19. Most of the events are online, so you can catch up. And with that being said, I think we can begin our session for the day. So what we're going to have, we'll begin with the introduction to DevOps. And this is critical because it will allow you to understand what's the big deal of CI/CD, where it should, when you need it and why you need it and how it comes to the world. And then we'll begin what I call a vanilla deployment journey. And this is basically just a basic deployment process that most of the deployment will go through. So we'll examine what we do and we'll try with each stage or each phase corresponding AWS service. We'll have demo/labs. At the end of the session, I'll be giving you links to the full guide of what we did today so that you can try it on your own, and we'll check how to go further from there. And by the end of the session, hopefully you will get a better idea about it and we'll have some kind of fun. And that's all what we're going to have today. So I think we'll begin. So what is the Devops story? The thing is that software development by itself, it's being developed over time. So many modern practices are coming out. For example, Agile. It's more agile to have more frequent releases, yet small frequent releases, say several times a day, and instead of having bigger changes every while. And another thing is microservices nowadays is to decouple a big complicated system into simple independent services. Nowadays also the culture to have teams working closely together and many other practices. But all these practices bring out operational challenges. For example, if I'm going to do more frequent releases, if I'm going to release a few change every day, how am I going to manage my infrastructure? How am I control the deployment? So a lot of challenges come with it when it comes to operating your system, and for that other new practices came to face these kind of challenges. So for example, we have nowadays the infrastructure as a code. This technologies or tool, you can, when you use it with automation, you can just easily automate your resources and your infrastructure, and maybe even automate your deployment. And a lot of tools and technologies came out for logging, for monitoring, for communication. CICD, our topic of the day, is one of the main practices, and I would say the best example that can describe DevOps. And all of these became what being called DevOps. So people DevOps means a lot of different things to different people because discussing around it covers a lot of ground. So people will talk about DevOps being just creating your infrastructure as a code. Maybe say it is automation. People will say it is culture. People will say it is tools. It is mindset. So it's a lot of things at the end of the day. One of the main uh, I would say main definition of it, and because this is its name come from, is that having the operation and development teams working closely together. In a traditional way, there is both teams are working in total isolation. So DevOps come and break this wall between these two teams, so they will be working closely together from the beginning to the end, from the source code until the system are up and running and monitoring the system. So it is a total change, I would say, in the culture and the mindset. But absolutely, to do this, you will need the earlier mentioned tools and practices like automation, infrastructure as a code. For example, it is infrastructure, but it is a code. So this is another example when it comes to DevOps. So with that being said, CICD is one great example of it. So before explaining what it is, let us go into a vanilla deployment journey. So every deployment will begin with a source code. The thing is, every system actually, at the end of the day, it's basically a source code. And for the source code, you need to manage it. So you will need a version control system. The system mainly will manage the changes to your source code over time. So it will keep track of every modification you did to your code in a special kind of databases. So if something went wrong or a mistake has been made, the developer can easily go back to earlier version of the code and troubleshoot any issue and check for the differences. And so the developers at the end of the day will be able to have a centralized location for code. They can easily merge and update their code. This all enable the teams to collaborate, to streamline the development, to resolve any conflict easier and faster. And one of the main version control system is Git. It is almost the source control management system, but honestly there is other, but it is like the dominant one when it comes on popularity, and it is an open source system that is used for project of any size. So it is very popular option for small to big enterprises. And Git is about having it allow you to have a Git repository. Git repository is like a virtual storage of your project and your source code. So it it is basically your source code, but it will add to it a folder called .git, sorry. So this .git will track all the changes and manage all the files of your project. And so Git allow you to control your version, to track history. It has a lot of features when it comes to collaboration and distributed development. And you can have it in your local machine, but there is a lot of hosting services. So you can put your project, not your own local machine, also your in any remote server, so that the team can all access one centralized repository. And one of the main hosting services is GitHub, and people a lot of times will mix between these both. They are totally different. GitHub is a hosting service for Git repository. AWS Code Commit is one example of GitHub Git repository hosting services, and that's the one that we'll be examining today. So Code Commit is a fully managed service, so you don't have to take care of the infrastructure behind it. It is scalable and highly available for you. It is secure, and the great thing, it's easily integrated with IAM, so that you really can control the access. So you can control specific action to specific people. Not all people can. For example, some people can like request comments, some people can approve it, or you can assign access per branch. It is you can really have granular access control on it. It has a notification, a custom script, so you can, if any action or for example someone has pushed a new code, you can easily enable notification that you are notified. It allows collaborating on code, but basically it is for private kind of Git-based repository. So today what we're going to do is that we'll create our own first repository in code commit. It's basic. So here I am under code commit. I'll just create a repository. I'll give it a name, CICD demo, and create. And simply I'll have a new repository, but I need to upload my code file. So before that, I have to have a user with proper permissions. So I have here, I created normal users. I just give him an AWS managed policy called code commit power user. Give him enough a privilege to do whatever required within code commit. And then you will go to security credential and HTTP get credential. You will create a new credential. So, and when you create it, you get to download it, and this is just like the access key. It is one-time thing. If you didn't download it, you lose it forever. So now that I got the credential, here's the shortest ever Git crash course. So I will just initialize my Git repository as being initialized. I will add, I tell it to add all my file in the current folder to this repository, and I will confirm it with a commit. So this is like the first commit, and it is being committed. So now that I did all that, I will need to push my code to code commit. So now I need to push my code, so git push. And if I go back to code commit, you click clone HTTPS. This will just copy the link. I'll paste it. I want it in a master branch, and it shall ask me for credentials. So here's it is asking me for the credential. I'm the one that I just downloading it. So this is the username and this is the password. And now it is being pushed. And if I just refresh this repository, I should see it there. So this is all my code files. I can easily open any and update it. I can have branches. So if you have some background with GitHub, it's quite identical or very similar. You have the pull requests and all the stuff of this. So this will end the part of source control management. But one last point is that code commit also allow a lot of integration with AWS and non-AWS services. So with CloudTrail and CloudWatch for logging and monitoring, we will be using it now with Cloud Code Build and a lot of AWS services. And so that now we have our code is managed well. Next, we need to build it, and basically it is about compiling your code, packaging it, any kind of processing you need it so that it is a usable application or system or services. So after building, you will do your test, and here we're just about the automated test like unit tests or any other automated testing, and for today we'll be using code build for that. So it is also a fully managed service, so you don't have to take care of any kind of infrastructure. It allows you to compile your source code, run tests, produce software packages that are all ready to be deployed. So it is also secure. The notification feature is also there, and the great thing about it is that has its built-in build environment. So if you need to build your code, you don't have to install or do anything that kind. You just you'll have the ready environment, but if you need some customization, you can customize your environment. And for example, for today we have a Java application. We'll use a built-in environment that can build our Java application into a WAR file. And how this is happening with a simple small file called build spec, and it is a collection of build commands that you give it to code to build, and you tell it I want to do this. It is very simple. It is just like I have the there's 3 stages: pre-build, build, and post-build. It's nothing special about it, just like the sequence. So here at the build stage, I want to run the test, and then after the build, I want to install my application, and the output, I need the WAR file, and I need other script file. This we'll need it at a later stage. We'll talk about it, so you'll know why we are keeping it at the output. So this is basically telling, yes, build it, run these build comments, and give me this file that been resulted from these comments. And for that, let us build our repository that we have just uploaded. So we'll go from code commit to code build, and I have to create a build project. I will call it demo build project. Nothing special. So I needed to build my repository I just uploaded. I wanted to build the master branch, so you can define a specific branch. For building, I'm going to use a built-in image, built-in environment. This Linux, the standard runtime, latest I can find, and it will create even the service role I need. I'm here just telling it that I'm going to use the build space file. I can here instead do whatever, any insert a specific build command or put another name for the file. I'll go with all the default patches, but I will tell her that I will tell it to give me some output. The output I specified on the YAML file, so I have to just select any packet I have and put the name of the artifact that will be resulted. So I'm calling demo build.zip. So I want it to be compressed as a zip. So it is zip. So I'm just telling it will be zip. Please compress it. I'll keep the logs, and I'll create a build project. I'm not still building. I'm just creating the build project so that I can easily run it later on. So now I'll tell it, okay, start my build. So now we're gonna start the build. All default, just nothing new here. I'll just let it to start. If you go to the face details, so this won't take much, but let us save time and go to next. So the code build has built-in environment for now we are using Java application or Java code. It has environment for Android, for .NET, for Node.js, PHP, Python, Ruby, or you can create your own custom build. You can create it for building your container image, for Docker or Amazon ECR. It can read from S3 EFS or can be used with Maven and Gradle for building. And I'm always keeping the links at the bottom of the slide so that you can go to the details if you are interested in any of these one. So let us just go back and check the status. It is still running. It will take just maybe a few seconds. It's done with what we built, but it is uploading the artifact. And it's all completed. So if you go to the S3 bucket, and refresh it, you should see the output we ask for it. This will include the WAR file and some script I needed for later stage. So now we finished with the code build. So we have the source code, we did the build and the test. All these stages is what is the CI part of our topic today. So it is called continuous integration, and the idea of continuous integration, it is just about integrating your code into one shared repository, and it's preferred or recommended to do it a few times a day, and it's for each code that's being integrated, automated, build, and test will be triggered. This is the idea. These are three stages are the continuous integration, but it has to be automated. With that three stages, we have only one stage left, and it is deploy. So I have now my code is being built and ready and tested. I can deploy it to different environment, for example, development and QA for UAT testing or production, or I can just go ahead and do it in a production. So now we'll deploy our built code into an EC2 server, and we'll be using AWS Code Deploy. So it is also fully managed, so no effort when it comes to the infrastructure. AWS take care of it. To offer automated deployment, as the name implied, so it allows you to deploy to EC2, Lambda, Fargate, and even on-prem servers. And the nice thing, it allows you to centralize the control of all your deployments. So you have the deployment history and infrastructure and monitoring and control all in one place. It is easily to adapt and offer a different kind of role deployment and like in a place and blue green if you want to minimize the downtime. It allows you to roll back if something went wrong, and you have also the notification feature, so you can add some notification if something went wrong. And it is very similar with code build with the YAML file. So it's also you instruct the service with a small script, a small YAML file. You give it like the shell. These are all shell script attached. These are the one we ask code build to keep it also. So because we need it for the deploy, these are very basic shell script. For example, the stop application is just system tomcat stop, just tell it to stop it. Whatever you do it in regular basis, you just put it in a script, give it to code deploy, and you tell it to do it for you. So now we'll do that. We'll go back to AWS and we'll go to code deploy. And for code deploy, you need to create first of all the application. We'll call it demo deploy application, and we want to deploy it to on-prem EC2. So let's create the application. Will be created. This number one. Number two, you create deployment group. So I'll tell demo deployment group, the service role. So you have to create a service role. For it, I'll leave it in a place. I want to deploy it to EC2. So you have to define what kind of EC2. So I have one EC2, just a new blank EC2. I give it the name Cicd. So okay, find one meshed instance. It will automatically install with system manager the code deploy agent that's needed for the deployment. I don't need load balancing, and that's all. So I create the deployment group. So this is only to tell it the hardware that I need to deploy to it. number 2. Number 3, I'll create the actual deployment. So I just click create deployment. I tell her, okay, I give it the file. So I have this build file that's being created from the code build. I just s3 slash, what was its name? Demo build. So demo build.zip, and so it will take it, extract of everything, and it will do the deployment. I'll go with the basic default settings and I'll create the deployment. And it is being started, it's being running. You can click view events and you can to see the stages. So application being stopped, it's installing. So meanwhile, let us continue until it's being deployed. So code deploy also integrates with a lot of things, and I'm mentioning the integration because it allows you to extend the abilities, and this is the great thing when it comes to AWS services. So it is integrated with CloudWatch, ECS. You can deploy to ECS. With Cloud9, with CloudTrail, and even you can deploy with Chef or from GitHub. Take the code directly from GitHub. There's a lot of non-AWS service that can be integrated with code deploy. Honestly, I'm not familiar with them all. No one, I believe, is. So I'm leaving also the links. You can see the sample or examples if you want to go further with that. So let me get back, and it is deployed. So if I go back to my instance and I take the public IP, this was a new instance, there was nothing on it. The script will install. So hello world, this is a sample application. Honestly, I'm not just Java developer, but I thought this is perfect example when it comes to build and deploy. So here it is on a server with Tomcat, and we got the deployment. And now you should guess, if we go back, you should guess that this is the last stage. So this is the CD part of CI/CD. This is the code deployment, or people call it the continuous deployment and or continuous delivery. And both terms are the same with one small difference. So the difference is that cloud deployment is triggered automatically. So whenever you have source code, you do the build, test, and deploy. But sometimes, in most cases, you have some kind of manual approval process. So if you have, like, for example, a small button for approval before it gets deployed, this is continuous delivery. But if it is automatically a trigger deployment with no human intervention, it is a continuous deployment. So these are the 4 stages, but still this is not CI/CD. Has to be automated, and this is with what they called it release pipeline, because it looks like a pipeline. So so what we're going to have today is AWS Code Pipeline, and it allows you to create this process automatically. So it automates these releases pipeline. It is fully managed and it's integrated with the IAM. So also allow you to control the access easy. It has a notification with many custom plugins. So now we'll go next and we'll see how we can automate all what we did, and it's quite super simple. So in pipeline, I'll get started. I'll create a pipeline, and all what is it is that you tell it all the stages. First of all, I will give it the a name, just any name. It will create the service role for you. Next, so I'll define the stages. So for the source code, I will have the code commit. I want to select my repository we created earlier, and for it is the master branch. And here you are saying I'm using CloudWatch because it allows you a trigger automatically. Whenever there is a change in the code, it will automatically build and test and deploy. So for the build, I'll also use the code build. I'll use the project we just created, and it will be a single build. And for the deploy, also I do the code deploy, the application we just created. Honestly, I forget. I think yes, it is demo DA, and the demo DG is that this we just created it. Next, and create pipeline. So now it will be created the pipeline, and it for the first time it will execute it. So just give it a few seconds. So you see the source, the build, and the deploy. Now the source is running, so it is just checking all the code, source code. Then it will run the build and the deploy. And the great thing about it is that whenever you do a change in the source code, this will automatically trigger. And you can even add or remove. So this is the basic, the vanilla, as I call it, journey, a deployment process, but you can add stages in between. So this is mainly it. Code pipeline you can use for the stage of the source code. We use the code commit. You can use GitHub or S3 or ECR, so integrated with AWS and non-AWS. For the build, you can use Jenkins or any other or many other build services. For the test, also we used code build for the same, but you can use, for example, Device Farm is a great application testing service, and we have today Community Day one session about it, or any other non-even AWS testing services. For deploy, you can deploy it to ECS, you can deploy it to S3 if it's static application, you can use it with OpsWorks or Beanstalk. So there is a lot of various options. You can use SNS for approval, so whenever there is it reach some stages, you send a notification through email. You can invoke Lambda to do some kind of changes. So the options are a lot. And again, the link, you can see example for most of the of the integration I just mentioned. So we just for last time we go, it's still, so it is redeploying. The nice thing, just to find it to be final thing, we go back to our repository and I click CICD and I changed any okay, I have spelling mistake in my pipeline. Anyway, so the great thing about it is that you can disable it if you don't want it automatically, but at the same time you can just, whenever you do any kind of so our pipeline has finished, you can easily change whatever you want to change, like hello community, hello AWS, let's say hello AWS community Fatema, and I will put whatever name, whatever email, and I'll comment the changes. And if you just give it a few seconds, you will see that it will be triggered automatically. See, it is now running. So it is running. So it's being rebuilt. It will be rebuilt and will be deployed here in a few seconds. And this is, ladies and gentlemen, all of it. I will be, after this session, I will be uploading all the code and the steps that has been done so that you can follow it on your own. The slides, I will be also uploading it. If you didn't see it by today, please give me a few days. And with that all, I hope you enjoy it. Thank you for your time. I hope you get some benefit out of it, and please feel free to ask. I'm around in the chat.